Hey gang, so here is another example of a significance test. This time I have the run data for first downs of the Green Bay Packers. So this is how many yards they gained on first down when they ran the ball. And we are going to run a significance test. I'm going to come back here to my hypothesis testing page. And this time now I'm going to say my null hypothesis is mu equals now running. Let's just do 5 again. Mu equals 5, and our alternative hypothesis, it will say maybe we believe that running it's less than 5 yards on average on a first down. So mu is less than 5. Okay. This time, instead of mu being the mean yards passing on first down, it's the mean yards running. Okay. So we need to get a p-value for this. So I need a random sample here. Again, I'm going to take a random sample of 20, so equals rand between 2 and now for our run plays, it goes down to 228. So 2 and 228. Okay. And I'm going to drag that down to row 21, because that will give me 20 samples. I'm just going to do a Control C, and then I'm going to right click and do a paste special, paste values only. Okay. Then I'm going to go to data, and I'm going to sort that by column P, A to Z. Okay. I'm going to look for any duplicates. Scrolling down this list, I don't see any duplicates, so I can continue on. I'm going to do the same thing I did in the last video. I'm going to insert a column here so that I can add a column to look up, so that I can make it a little bit quicker when I'm trying to find these values. So if I go back up to the top here now, I'm going to do equals VLOOKUP. I want it to look up this number here, the 6. I want it to look it up over here in these columns, basically in column K. And then I want it to return the number that's in the second column, that's in column L. Okay. I can close the parentheses and I can hit enter, and that's 21. And if we take a look, number 6 is 21. Okay. Remember, before I can drag that down, if I drag that down right now, it changes the 2 and the 228 there to a 3 and 229, and I don't want it to do that. So I'm going to put a $sign in front of the 2, and a $sign in front of the 228. And now I'm going to drag that down, and I've got my 20 values. And so now I'm going to Control C, copy those. I'm going to go over to Desmos, and I'm going to paste those in. Pasted them in after the rest of those, so I'm just going to delete the rest of those. A equals, all right. So now, I said, again, my null hypothesis was that mu equals 5, so I'm going to say t-test a comma 5. Here it was less than, and so my p-value is 0.32. Okay? So if I go to my hypothesis testing here, I got a p-value of 0.32. So that means assuming the null is true. So assuming that the mean number of yards gained on a first down by running is 5, there is a 32% chance that we would see our results or more extreme purely by chance. Okay, so pretty high probability that this could have just happened by chance and that there's nothing wrong with the null. Okay? Because of that, since our p-value is greater than 0.05, we fail to reject the null. Okay, we don't have any reason to believe that the mean isn't 5. Okay? We fail to reject the null. We do not have evidence that the mean number of yards is greater than, or excuse me, less than 5. Okay? So that's, again, another hypothesis test. Again, you don't want to do this ahead of time. You want to choose your null hypothesis and set it. Okay, but just for the sake of looking at p-values here, if we were to change that null hypothesis to something like, let's go a little bit bigger here, 7. Okay, so maybe we believe that the average run play on first down typically gains 7 yards. Okay, well, if our alternative then would be less than 7, and we believe it's less than 7 yards, there's only a 0.02, so a 2% chance that we would have gotten these numbers up here if the average is 7. So that's not very likely to happen, which means either this just wasn't very likely to happen up here, or the mean isn't actually 7. Okay, and so what we say is that since our p-value in this case would be below 0.05, would be less than 0.05, we have evidence to reject this null. We have evidence to believe that it's not a mean of 7 and that it's actually less than 7. Okay? And if you look at, these values, it does appear that it's less than 7. I mean, the mean of these values here is 4.45. Okay, so that is less than 7, and it's far enough away from 7 that we believe, based on this p-value, that it's unlikely we would get this mean if 7 is the true mean. Okay, so that's another example of a hypothesis test. I hope that helps. We'll be seeing more of these hypothesis tests if you take probability and statistics, or in particular AP statistics. Thanks.